everyone, and welcome to this video on simultaneous equations with more than two variables. I'm going to jump straight into this, but I will go through a few different methods. We'll have a look at doing these on the calculator as well. Now, to begin with, I'm going to solve this using elimination. So I want to get, I should start off by saying at the moment we have three equations with three variables, and this is always going to hold true, this pattern. So however many variables we need the same number of equations in order to solve them. Okay, so three variables require three equations, four variables require four equations, and so on. What I'll also say is that these questions are not common on exams, but what I would also say about it is that these ones are very good to practice in terms of just your algebra skills, that sort of thing. And on top of that, if you have any intention of studying any kind of mathematics at a tertiary level, you can definitely expect to encounter this kind of thing. So to begin with, what I'm noticing is that the third equation here is already in terms of just two variables. So I want to make one of the other equations in terms of just two variables as well, in terms of just x and z. So what I'm going to do is I'm going to do equation 2, and then I'm going to subtract, or even add, I should say, 3 lots of equation 1 to it. Because, well, if I do equation 1 multiplied by 3, I'll do that off on the side here, then that's going to give 12x minus 3y plus 6z equals negative 21. Should technically call it 4. So that's equation 2 plus, now what we have is equation 4. And so when I add those two equations together, 2x plus 12x is 14x. 3y plus negative 3y cancels out. Negative 5z plus 6z is just plus z. And then we've got negative 4 plus negative 21, which is negative 25. So I'm going to call that equation 5. And now I'm going to work on equation 5 and equation 3 together, because these two, I'll just rewrite them again down here perhaps. So I've got negative 3x plus 4z equals 18, and I've got 14x plus z equals negative 25. So what I might do now is I might do equation 3 minus 4 lots of equation 5. And that's because that's going to make a 4z term. So we've got negative 3x, take away 4 lots of 14. Okay, so that's going to be negative 3 take away, what, 56? So negative 59x. 4z take away 4z would cancel out. And 18 take away, well, 4 lots negative 25 is 100, and that's a negative 100, so it's 18 plus 100, which would be 118. We can divide both sides by negative 59 to get x equals negative 2. So the next thing is to then substitute that into one of the equations. I'm going to sub it into equation 3, and so that's going to give, just check I got that right, so negative 3 by negative 2 plus 4z equals 18. So that means 6 plus 4z equals 18. Subtract 6 from both sides to get 4z equals 12. Divide by 4 to get z equals 3. And now I've got x and z. I can sub these into one of the equations from the beginning to get y. So I'm going to sub that into equation 1. So that was 4x minus y plus 2z equals negative 7. So that gives negative 8 minus y plus 6 equals negative 7. negative y. Now minus 8 plus 6 is minus 2. Add 2 to both sides. And so divide by negative 1, we get y equals 5. And there we have it, the solutions for x, y, and z. As said, we'll also have a look at this on the calculator. So I'm not going to go into doing this by substitution. While substitution does work, it's really messy and just kind of pretty horrible to do. So much better to use the calculator here. I'm going to show you 2 different ways to do this on the calculator. So firstly, we can use the simultaneous equation solver. Here it is. So I've hit that once, push it one more time, it adds in an extra row. And if I just write the equations in, 4x minus y plus 2z equals negative 7. The second equation, 2x plus 3y minus 5z equals negative 4. And the third one, negative 3x plus 4z equals 18. And I solve it for x, y, and z, remembering to separate each with a comma. Then it tells me x is negative 2, y is 5, and z is 3. Alternatively, you might remember to solving equations using matrices. So any kind of equation can be written in the matrix form AX. Oh, what's going on here? Equals B. Okay, where A is the coefficient matrix, X is the variable matrix, and B is the solution matrix. So in this case, the coefficient matrix is just the coefficients of all of the variables there. So it's 4, negative 1, and 2. And then it's 2, 3, and negative 5. And then for the third equation, it would be negative 3, 0, because there's no y term, and then 4. So that's the coefficient matrix. The variable matrix is just the variables in the equation, x, y, and z. And the solution matrix is the numbers on the right hand side of the equation, so negative 7, negative 4, and 18. So the thing is, you might also remember that there was no way to do matrix division, but we could do the inverse matrix. And so we could rearrange this equation to say x is equal to the inverse of A multiplied by B. And that's all I'm going to do. So when I do this on the calculator, just move this over here a bit, or even I'll put it over here. So this is your other way. I'm going to put in the 3 by 3 matrix with 4, neg 1, 2, 2, 3, neg 5, and then neg 3, 0, and 4. I'm going to put that to the power of negative 1, and then I'm going to multiply it by the solution matrix, which was negative 7, negative 4, and 18. And if I hit execute now, I can see x would be negative 2, y would be 5, and z would be 3. So again, just a different way of doing it. And again, you can choose whichever one you prefer. Anyway, leave it there and see you all later.